now you should have many tools in your integration toolbox, but none of the tools seem to exactly fit an integral like we have here. What we're going to do is take this integral and split it into several integrals, each of which we have tools for. So, how do we split a beastly integral such as this into smaller integrals? The answer is to take the denominator of the fraction and split your integral according to the denominator, as so. So I'm just going to let this object here that I'm trying to integrate be equal to a sum of other smaller fractions. So I'm taking the x plus 1, there's an a over x plus 1. I take as many of these factors as x plus 2 as I have, and then I just kind of incrementally build them up like this. So I take one x plus 2 factor, then my x plus 2 factor squared, and then I'm done. But if I had an x plus 2 cubed here, I'd need a d over x plus 2 cubed in order to complete this. Okay, so let's find out what a, b, and c are. So I obtain this lovely polynomial, and then I obtain it by multiplying this thing here through by the denominator. And this is nice because I can start plugging in some values of x, some strategically chosen values of x, to discover what my a, b, and c are. So if I choose x equals -2, that's a great choice of x, because this side, well, this side's just 4 minus 2 plus 2, which is 4, and the right-hand side becomes 0 plus 0 plus c times -2 plus 1, which is -c. So, cool, good choice of x, good choice. Let's do it again, but this time for x equals, I don't know, -1. Then 1 minus 1 plus 2 is 2, and this side becomes a times -1 squared, which is just a, and the right-hand side is, this is 0, and that's another 0, so just a. So, good. I have to work a little bit harder for b. There's nothing easy I can just substitute in here. But what I can do is compare coefficients of x squared. This leads me to, well, on this side it's 1, and on this side it's a plus b. And I already know a, that's 2, so b must be -1. Great, so I've got my a, b, and c. Okay, here we are. So I've just plugged in the values we found for a, b, and c, and this is something we can integrate. So since this ugly thing here has this lovely decomposition, so I can write my integral of I like this as a sum of 3 integrals, each of which I already know how to do, because these have, there's tools in my toolbox for these. Good, and so each of these was relatively straightforward, and that's the answer.